Okay, let's try to finish up this checkup in 3.1. Train A begins at Central Station, 40 miles from the city of Ames. It leaves the station and travels away from Ames at a steady speed of 60 miles per hour. That's your slope. That's your rate of change, 60 miles per hour. Train B travels in the same direction at the same time, beginning from East Station. Its distance from Ames is represented by the graph. Okay, so let's look at what they're asking us. Which train travels at a greater speed? So we're talking about the slope here. Train A is 60 miles per hour. We need to find the slope for the graph here. I'm going to zoom in a little bit so I can see. Okay, so this is going by 20s. If I go up 20 and over, what would this be? Let's go up from 20. Let's do this. Let's say one of our ordered pairs is 0, 20, right? We're going to do this using slope formula so we don't mess up on the graph. Another point is 1, 100. Okay, so I'm going to go to my paper here. Here's our 2 points. 0, 20, 1, 100 were 2 points on this graph. So if I put those in slope formula, 100 minus 20 over 1 minus 0, I get 80 over 1, which is just 80. So this is train B is traveling at 80 miles per hour. Train A is traveling at 60 miles per hour because that's what it tells us. So here, train B has a greater speed. It's 80 miles per hour. When it left the station, I'm going to go back down a little bit. When it left Central Station, train A was blank than train B. Okay, so let's look and see. So now we're talking about the y-intercept. Train B was 20 miles from the station. It says train A was 40 miles from the station. So train A was 20 miles closer to Ames because it was already 40 miles from the city of Ames, and this was 20 miles from Ames. Actually, yeah, train A was 20 miles further. I'm sorry. Okay, so let's do that. Next question. I've got 2 minutes. Hopefully there's not many more. Okay, Shakita buys an apple tree and a cherry tree and measures them at the end of every year for 5 years. After 1 year, the apple tree is 14 feet tall. So that's an ordered pair right there, 1, 14. After 5 years, it is 22 feet tall. That's another ordered pair, 5, 22. The cherry tree's height is represented by y equals 3x plus 8. Okay. If both trees grew at a constant rate, which tree was taller when they were planted and which grew more quickly? All right, so let's read this one more time. Shakita buys an apple tree and a cherry tree, measures them at the end of every year for 5 years. After 1 year, the apple tree is 14 feet tall. After 5 years, it is 22 feet tall. That's the apple tree. Okay, and then the cherry tree's height is represented by that equation. So I'm going to go to my paper here to show you what I wrote down. The apple tree, we have these 2 ordered pairs. After 1 year, 14. After 5 years, 22. The cherry tree is written by this. So this is our rate of change, our slope, our rate of change. This is our y-intercept or our starting point. So when it asked how tall it was 8. So let's go back here and look at this again. Which tree was taller when they planted and which grew more quickly? So let's look at the slope here. 22 minus 14 over 5 minus 1 is going to give us 8 over 4, which is 2. So this slope is 2. This slope is 3. I'm about to run out of time. Okay, so let's see. The cherry tree was taller when the trees were planted. We need our y-intercept, so let's look at this. If the slope is 2 per 1, and my time is going to run out, so I'm going to have to make another video. So stay tuned for the next video.